If you are currently leveling up your Django and Postgres skills with this tutorial, you might like to know that this tutorial is part of a whole playlist where you will learn how to, with Django and Postgres, create database level constraints and triggers. If you like this playlist and you would like to learn more about Django ORM, then do check out our Django ORM Mastery course on Udemy. Links to the playlist and course can be found in the video description. So we're going to be creating some validation at the database level. Now, PostgreSQL supports several types of constraints to ensure the integrity, accuracy, and reliability of our data stored in the database. So you can go ahead and check out and read these in a little bit more depth. Head over to Google, type in PostgreSQL constraints. It should take you to the constraints page of the documentation, and you can read through them. Alternatively, you can ask ChatGPT to give you a breakdown, but here are 7 different types of constraints that we can apply at the database level, which we're going to be utilizing. Now, some of these constraints will be automatically set up when we create the table. So, for example, primary keys, foreign keys, that will automatically be defined for us. But there are some other constraints here, for example, check extra constraints, unique constraints, that we can apply once and after we've created the model, Django models in our database. And it's these that we're going to be focusing on in this section or this module of the course. So let me give you an overview of check constraint, which we're going to be utilizing. This is going to ensure, for example, that values in a column meets a specific condition. So this is going to take our database to the next level potentially, because let's just take, for example, the category table that we have created here. Now we have a field called level, which is going to have a number, an integer field, and that number can be between maybe 1 and whatever, because it's an integer field. But we might have a specific need to ensure that this level field only contains the value, say 1 to 10. And that's the only values that should appear. And that might be specifically important because of how our application works and manages that data that's returned. So it may have a massive effect on the actual data, on the actual system that we're developing. So it'd be important to ensure that this data, or the expected data that this returns, is either value 1 to 10. So this is an example where we would need to set up a check constraint. We need to ensure that the value in this column meets a specific condition. In this case, level is equal, or level is greater than or equal to 1 and less than or equal to 10. If you take a look at the constraints and triggers table here for the category table, you can see that we have a few different checks that we're going to need to create. One for level, one for the slug, and again for the name. And I'll take you through that step by step when we do that for those tables, and in fact all the tables here in this database. So to summarize, here in the world of Postgres database, there are multiple types of constraints that can be applied. Some automatically created when the tables are created, some we would define manually. Our goal, it will be to define the needs and expectations of our data stored in the database, and then of course determine whether we are going to create validation at the software level, application level, or whether we're going to define it at the database level. Of course, what we're going to do now in the next couple of tutorials is apply validation at the database level utilizing PostgreSQL constraints. In addition to creating some constraints, we're also going to be building some simple triggers. So here in PostgreSQL, a trigger is a database object that automatically executes or fires a specified function, known as a trigger function, when certain events occur in the database. So these events can be data modifications such as insert, update, or delete operations on the table. So again, let's just take the example here of our category table. Where might we add a trigger? So again, I'm obviously just making this up, but you may have this actual requirement. So I've made a requirement that the category table here, the name must be in lowercase. So I have this specification that all the names must be lowercase. That makes all the data completely uniform throughout the whole database. So in some cases, someone may try to include a name of a category which has uppercase letters or other special characters, and I want to avoid doing that. And of course, what we can do is we can add that validation to the application level to prevent that from happening. But of course, here we're working in the back end, and we want to add that validation here in the back end in our database system. So here we're going to create a trigger so that any data that is trying to be inserted into the category table, a trigger is going to be initiated, and that code is going to take that name that's being inserted and it's going to then make it lowercase. It's going to potentially remove any special characters and make it lowercase. Now, it's not going to get any more complicated than that. We will utilize that trigger, no doubt, in multiple tables. But in summary, PostgreSQL triggers, they are powerful tools for automating database tasks, enforcing business rules. That's what we're going to be utilizing it for, and maintaining data integrity. But we need to make sure that we're using it sensibly and in a way that we're trying to avoid any unnecessary complexity and potentially performance issues. This, of course, is one of the potential drawbacks. Any triggers or constraints that will need processing, so that will be utilizing your server resources, potentially slowing down the performance of your database. Hopefully that's given you a starting point. Of course, now we're going to apply this concept of triggers and constraints in all of our tables in our database.